Good morning, everyone. I think we had a very thought-provoking speech by Dr. Terence. So today, AI is taken indoors into each and every industry, every verticals actually. That's why you can see diverse, industry speakers here in the panel. And it's going to be very interesting to hear about experience from each and everyone actually. Just before starting that, because today everyone is talking about Industrial 4.0, so my definition of Industry 4.0 is about convergence of computing, connectivity, and cognitivity. So today we are going to focus more on the cognitivity. So let's start with introducing everyone. I am Ravi Kumar from Lloyd's Register. I am heading the technology and innovation, focused more on big data analytics and artificial intelligence. It's all about digital. Everyone is getting disrupted by the way digital tsunami is coming in. So everybody is in the race of getting into digital innovation and digital transformation. So my team works more on digital innovation, and then we are trying to inspire our customers with our new innovations in machine learning and predictive algorithms, etc. So that's what my introduction is about. Dr. Partha, you can start. Yeah.
Hi, good morning. This is from SEMCorp. I head data science globally. SEMCorp is an integrated energy company. So with data science and related technologies, we are trying to improve the efficiency of our business process, as simple as that. Well, it's a little bit challenging doing than saying, but we are bringing innovative solutions around machine learning, artificial intelligence, and optimization to make a step change in our business process efficiency across our value chain, from production through to trading and retail across the world.
I'm Lawrence. I've always been in this AI space for some time. I remember doing machine learning more than 10 years back. In fact, some of my colleagues are here in the audience. It's very nice to see some of them. I was doing machine learning in my PhD. After that, I became a scientist. I applied machine learning to different types of healthcare data sets. Then after that, I crossed over to the dark side. I went to industry, and I joined a pharma, and then I joined an insurance company. But all this while, I've been doing a lot of AI and machine learning, data science, and health. So it's quite exciting to be here with the rest of the panel.
Hi, my name is Sigrid. I head the data science team at SGX. Before SGX, I worked in several different industries. I studied as well in research in A-Star, and then I worked in FMCG, telco, and now finance. My current role at SGX was to set up the data science team, so I built up the team, put up the platform, all the processes around, and decided on all the use cases that we are currently working on. As a data science team, we are mainly internally focused, but we work with all the different business units across all the different businesses, but we also support operations technology.
Morning, everyone. My name is Jason, and I lead the AI team in MSD. MSD is one of the world's largest pharmaceutical companies, and some of you might know it as Merck, its name in the US. I lead the AI team as a distinct part of data science. I think there is sufficient differences in the value proposition of AI, the engineering part of AI, and also the skill set needed for AI that we've kind of managed it as a distinct part of data science. In terms of my background, I'm one of those leaders who is kind of like broad and maybe not so broad and shallow. I do not have a PhD, but I've went back to school 3 times. So I have 4 degrees, 2 in tech and 2 in business. And I think very much that the value in the future is in the gaps, because many of us, we study and grow up in silos, and as things converge, we need more cross-discipline action. In terms of the company, you can think of the pharmaceutical industry as 3 distinct businesses. One is inventing drugs, which is before data science, there was science. So you have things like deep learning for drug discovery. And then besides that, you have manufacturing, which is very much like the Rolls-Royce talk, which you just heard. And over there, you have the applications of computer vision and IoT and everything that deals with large physical spaces. And finally, you have the more traditional commercial organizations, which is very similar to some of the talks we hear in the customer experience world today.
Hi, good morning, everyone. My name is Sutowo. I lead the Analytics and Information Management Division in Ministry of Health Singapore. So in terms of the work, for me, really is around a few areas. One is how do we identify and also translate problem statements in the ministry into data and analytics requirements. How do we do the prioritization, because we do have limited bandwidth in terms of what we can do. So the prioritization is important. Another key area I look at is how we organize and manage our data assets. I also look at capability development, not just for the data analysts and data scientists in the Ministry of Health, but also the broader organization, looking at how we can improve data literacy for everyone in the ministry. And last but not least is really also around the delivery of the use cases. So application of ML, AI, or even some more simple data visualization techniques that help us do so. In terms of my experience, I've always been a consultant. I've been doing data analytics consulting almost life until I joined MOH. So I've been with firms like Accenture, Deloitte, before I actually joined MOH.
Okay. Hi, my name is Ankur. I look after data and technology innovation in AXA for the Asian region. So I've been in the lab. Our mission is really to transform AXA into a data-driven organization. So and also exploring emerging technologies. So in fact, the way we look at it is we call or divide the AI into three parts: perceiving, thinking, and acting. So perceiving will be very much about technologies around computer vision, IoT, et cetera, et cetera. Thinking will be very much around data science and ML, and also visualization. And acting will be things like RPA or things like chatbot, where you're delivering insights to the customers. So we work on all these different areas and continue to transform the insurance company. In my experience, I've been in financial services, in insurance for all my career, basically, but more in the analytical profiles. So in the last 4 or 5 years, I've been working more in the data science and technology innovation area.
Great. So we have 2 panelists from healthcare, and we have 2 from industry, and then we have 3 from finance. And fintech is, it's really leading the artificial intelligence a big way. So Dr. Sigrid, it's like you are from AGX, Stock Exchange. I think that's a very, very time-sensitive information you handle. Like even a glitch, makes a major difference in the stock trading. So how do you really cope up with that, the time-sensitive environment, and how you're using the artificial intelligence to help you enhance or make the traders more efficient in trading the stock exchange?
Okay, so as an exchange, we don't do any trading. So we just provide the platform to facilitate the trade. So time is very sensitive in the sense that our customers trade in nanoseconds. So the way we have set up our data platform is able to capture all this resolution. So we have chosen a specific technology to be able to capture the data in real time. And we have a data engineering team who makes sure that all this data is available all the time, 24 hours a day. In terms of AI, as of now, we still run, so what we do is we train our model on, let's say, a weekly or a monthly basis, and the scoring can then happen in real time. So this is how we deal with the real-time piece. So the scoring happens on the database that allows for the nanosecond resolution, but the training doesn't necessarily need to be in real time as of now. This is not something that we really need. So we don't need to put all the efforts in terms of the technology to have this happening as of now. If this becomes a new concern, then probably we'll leverage more cloud technology where we can allow to have like a temporary increase in terms of capacity.
Yeah. Thank you. So the insurance industry is also using AI a lot. because there's a lot of fraud in insurance. So do you use a lot AI in predicting fraud? And also, how do you really predict the customer trends in terms of even attracting to the insurance industry? So you can add how we use AI into that.
So I think when it comes to fraud in general, I think, let's say if you talk about health insurance, we believe the global average is about 10%. And we don't call it as only fraud, it is actually fraud, waste, and abuse, because sometimes it is overutilization of certain benefits. So doctor is doing additional diagnostic test, which was not supposed to be done, etc., etc. So definitely there are lots of ML techniques that we have deployed, and we continue to enhance these technologies. Idea is to detect, is there an overutilization? Is there a fraud, actual fraud? Is there an abuse? And depending on the line of business, if you talk about health, the fraud could be because of the customer, because of the provider, because of the treating doctor. It could be a combination of all these factors. And the advantage is that if you can actually detect it properly, then you can streamline your claims processing. Because today the challenge with all the people will be that why is insurance companies taking so much time? Why are they investigating our claims? Why are they asking for so much documentation? But if we can be very good at it and we continue to move in that direction, then obviously the claim settlement cycle will clearly reduce because we will be easily able to say, yes, this is a genuine claim, let's pay. So a lot of examples that we have worked on are also in the STP case, straight through processing. That if there is a certain pattern to a claim, can we actually, without any due diligence or without much, can we take an automatic decision on that? So again, that's an area where we continue to explore. When it comes to an insurance company, obviously, even at the start, when you're buying a policy, there will be questions on underwriting. Are you medically fit? If you're talking about either a life or a health insurance product. If you're talking about a commercial insurance product, it will be what kind of practices you have in your company. So again, a lot of ML techniques, AI techniques can help there, where you can straight through the processing, where you can reduce the underwriting criterias because you have access to either more data or more insights through either external environment or through your partners. And you can actually leverage that to deliver those insights and make sure that your underwriting is fast-tracked. So clearly in the entire value chain, we will have a lot of areas right from acquisition to claims to servicing, where usage of additional data and technology can help you in taking a decision. And you can be more efficient and obviously reduce your speed to market in all these different areas.
Right, so we see fraud in different angles, right? So I bring one example. Fraud can happen in a way which everybody knows is fraud, right? So we have the data for it already. So fraud can also happen in a way which the insurers don't know, right? That it's fraud, right? So it's basically the unknown unknowns. So for those cases which fraud is known, it's visible and the industry knows about it, we have a lot of data. So for that kind of fraud, it's actually quite easy to build analytics and machine learning models on, right? And that's what we did actually in Allianz. In Thailand, we have this problem with motor claims fraud. It turns out that some of the workshops that the cars are being sent to, the workshops actually claim for parts or they note down parts which are not damaged as damaged, right? And they also noted down parts which are damaged to be more serious than it actually was. So there was a big problem here because it's obviously costing the insurers a lot of money, but thankfully we actually have lots of data on it. And people who are actually working on those cases know that there is fraud. So with all these data points and domain knowledge, it's actually quite easy to build machine learning models on. And we actually built a very simple tool to allow the claims assessors to determine very quickly if this particular claim is fraudulent or not, right? It's a like visual dashboard with like yes or no, with a score and things like this. But what we are more concerned about is actually those cases which is the unknown unknown, right? It's actually fraudulent, but nobody knows about it, right? So it goes unnoticed for a long period of time until we get a little bit more data, people are a bit suspicious, and then they drill down into the details and then realize that there's a bit of fraud going on. So there's two dimensions to it. One is noticeable, easily solved with analytics, and the other part of fraud is actually harder to catch. It's harder to build models on.
Okay. We did some pilot project on elderly care in Europe. So especially Norway is leading a lot in elderly care. All the Nordic countries, for example, Sweden, Norway, etc. So I would like to ask a question in Singapore. So how we are using the technology, especially AI, to improve the elderly care experience and also avoid a lot of elderly people coming into the hospital and occupying the beds. I think that's one of the major problem in UK and also in other European countries. So how Singapore is, making arrangement or handling that?
Okay. So on that, some of the things that we are doing, just now I mentioned about admission to hospital or sometimes even readmission. So we recognize that as we look at the data, there's quite a small group of patients who get readmitted very frequently. And that's the starting point in us drilling a bit more into it, and we find that actually a lot of the readmissions are avoidable. So what we have done is to build a readmission prediction model that has already been applied to all public hospitals in Singapore, where we give a score when the patient has an unplanned admission through the emergency department. What we do then is to give a score based on the data from the patient on the likelihood for readmission. And those who are actually highly likely to be readmitted, we will enroll them in a program called Hospital to Home. So the whole idea is very simple, right? Post-discharge, we want to give support both from a social and medical standpoint to the patient so that they can stay well at home. Because once we do so, the likelihood of them coming back to the hospital is a lot lower. In terms of experience of patient, another area that we look at is from a service planning standpoint using geospatial data. So we look at whether there are imbalances between supply and demand, not just today, but also projected into the future. So we do look at quite long-range planning, minimum 2035, if not 2040, to look at what are some of the projected demand that we see across the different locations in Singapore, and also what are the planned expansion in terms of capacity, and then where there are still imbalances, we will then decide where to locate or site some of these facilities. And increasingly, we are moving a lot of care out of acute hospitals because we also recognize that it's best for the patients to be kept nearer to home in the community. And that's also where it's actually less expensive and more sustainable for the system as a whole. So we do look at a very careful planning in terms of where we site a lot of these facilities.
Thank you. Well, Jason, like nowadays with retina scan, so you can find a lot of physiological parameters, also you can predict and you can also diagnose with, what kind of problem a person may have or will have, right? So how these pharmaceutical industries are using this kind of data to improve, the medical intervention or medicine? So just like to give some insight on that.
Yep. I think when we think about AI and medicine, there are two very different worlds that we need to bridge. One world is things you might see on the internet where our digital health is so exciting and we are going to replace radiologists, we are going to use retina scans like in the movies and all these things. And the other world is the world you walk into when you come into work on Monday morning, where you have a very highly regulated industry with layers and layers of processes. Just to illustrate this a little bit more, the two worlds in pharmaceutical, when we think about data, is the first world is clinical trials, where you have very small amounts of very high quality, very expensive, very curated data. To just get one row of data is a lot of trouble, many months or years of work, and very high cost to make sure that the data quality is very good. On the other side, you have things like your Fitbit, where you're like, oh, did I do my 10,000 steps today? Let me shake a little bit. Oh, I have 10 more steps, I'm done. And so you have this very high volume of very cheap and very low quality data. And so I think the trick is bridging these two worlds. You really do not want to have a drug that is invented on the basis of your fake Fitbit data. On the other hand, you don't want to close off the world of medicine from all these new technologies and all these data sources as well. I think one very interesting development in this space is we have this thing in the industry called GXP, which is G stands for good, X is any letter, and P is practice. Good clinical practice, good medical practice, and so on. This year, there was a very interesting development by the FDA where there is good MLP, which is machine learning or software as a medical device. So the entire industry is tooling around getting ready for when this thing passes into regulatory approval. And so we'll see, we are getting ready for a big boost in this area.
Thank you.
So maybe I can add something to, since I'm in health as well, right? Yeah. So I think one of the growing concerns in health is the issue of maybe liability, right? AI products. Increasingly, we are seeing more and more AI products for health, right? The first FDA approval for heart volume detection was approved in 2016. Now we are seeing more and more FDA approvals of products that could diagnose disease, recognize images, and blah, 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 blah. So I think increasingly we will be very concerned about how do these things work, right? I mean, if they're accurate, can we trust them fully? If they fail to work, who to blame? Do we blame the machine, or do we blame the doctor? And also the issue of explainability, right? I mean, so the AI is usually black boxed. You don't really know how they make the decision. Sometimes you know, sometimes you don't, depending on the algos that you use. In this case, in medicine, it might be an issue, right, among doctors and patients and how they actually translate the information of yes or no to the patient and to what degree. So I think it's a tricky stuff. I think we are still at the very beginning of understanding how to build a framework around medicine and AI.
May I quickly just respond to that? So I think I'll go with a yes but. And the yes but is that 2016 was a very interesting year for model transparency. So I think we often hear in these conferences, oh, it's a black box, it's a black box, black box is a problem, it's a black box. But I would say that as of today, 2019, we are in gray box territory. Right? So if any one of you is interested to investigate this space a little bit more, a great starting point is DARPA, the US association, who is one of the leaders in explainable AI, and they have open source lots of this work. So you'll see vendors, you'll see providers, you see internal teams like many of our teams starting to implement layers on top of our models to make the models more transparent, more interpretable. So I just want to flag that I think the days of a fully black box model is starting to wane, and lots of the work that we do is getting more and more transparent.
Thank you. So I was involved in one of the pilot in Europe again that, how do we really optimize the trash bins? So we provided sensors and trash bins and see whether it's full or not, when it has to be emptied, so that we can increase the efficiency of the workers, because sometimes in Europe it's difficult to get workers to do these kind of jobs. So how in Singapore we are doing with, like you said you are from Samong Waste Management or Samong? Yeah.
I'm from SEMCorp.
Okay, sorry. So how some of these AI techniques used in the industry you come from?
So just to clarify, SEMCorp is an integrated utility, power and utility company with a global presence. I think it's safe to say that most of our day-to-day experiences with the waste management trucks, that's only a little bit of the business. When I say integrated power and utility company, it touches on thermal power, renewable energy, water treatment, and the entire value chain associated with that. So we are producer of power, we are distributor, and also we are retailer of power. As you know, in the Singapore market with the OEM in place, you could potentially be getting your electrons at house from our operating plants in Jurong Island, potentially, if you have signed up. So coming back to the question of what we do with data science in a highly industrialized company like SEMCorp, global company, with multiple business lines, multiple markets. Firstly, it's all about optimizing our performance. Whatever we do with AI or machine learning or optimization, it has to be tied with a dollar number, figure, that is either related to bottom line, whether we are optimizing cost, efficiency of operations, or the top line, which is, are we generating more than we usually could, or creating new revenue channels? So these are absolutely the guardrails, the drivers with which we work when we do data science and AI in SimCorp. So we are, as an integrated company, the challenges the business and any typical utility company across the world would have cuts across the entire value chain, whether it's a production problem in the operating plants, in the power plants, whether it's a trading strategy in the forward-looking, in the downstream part of the business, it's a retail problem, for example, customer churn, or it's an internal business process optimization. Data and the data science challenges or opportunities are across the entire value chain, which means that it's no single use case. We have multiple use cases that has a wide, diverse sort of nature that we are addressing today with optimization technologies, with machine learning and AI. The other sort of thing to note in a company like SimCorp and any other power and utility company, these problems are today's problems. We have very little luxury of focusing on an R&D program, future-looking. We have issues that we need to resolve today with our operating procedures, with our production efficiency and profitability. You will know with the platform business, there are with the market getting disrupted with new regulations, with the renewable energy becoming a key part of the energy mix as opposed to the traditional power sources. This is creating unforeseen levels of disruption in the market where utility companies are operating. So we need to adapt, and we need to optimize our existing processes simultaneously using digital, using data science. So it's a problem we are solving today. It's not something which is going to hit us in the next few years. Why that is important? That is a philosophy we are adopting within the data science team, that we are focusing on building production-ready applications that are scaled at an enterprise level, that we can roll out immediately across our global markets, across business lines as soon as we can, to make sure that transformation happens now. So transformation, we talk about digital transformation. It's a favorite term these days for us. Digital transformation starts from the beginning of us taking a project on, by bringing the right technology, right people, and right processes along the journey. So it's not a nice thing to have within SimCorp. It's an integral part of the business strategy, data science. I hope that makes sense.
Thanks, Dr. Pata. So just coming back to renewables, because renewables, when it comes to renewables, it's all about feed-in tariff, right? So that means the revenue is almost fixed. So if it is related to feed-in tariff, we go to solar farm or wind farm. So I have a question that, because their optimization is extremely important, especially optimizing the cost. So how do you use some of these digital technologies, artificial intelligence, in terms of creating a digital twin out of a wind farm or solar farm, and then trying to make use of these technologies to optimize and make a cost saving out of it? So can you give
There are two aspects that I have experienced so far related to renewable. One is the unpredictability of Mother Nature. And that is a problem any renewable generator company, whether you are generating power or whether you are providing OEM, will encounter. So how do you maintain a certain level of predictability and constancy of your production and therefore your revenue stream is a big, big challenge. So a lot of our investment in digital and data science focuses on making sure we are predictable and we are stable in our production of renewable power. And that supports both our long-term, short-term contracts, but also the sort of the trading opportunities. Because if your source of power is fundamentally unpredictable and you don't have any control over its stability, then the rest of the downstream becomes quite shaky. So that's one area in terms of understanding predictability and stability of generation. The other area is obviously supporting the trading aspects, which is a whole area of its own, with its own challenges and all that. The third area, probably I should have mentioned 3 areas, is the microgrid concept in emerging markets, where renewable power is only one source of energy that's providing the electrons. The others could come from batteries, traditional sources like gas plants, etc. And how do you combine them optimally as a microgrid to support, say, a local region or even a local customer that may not be able to afford drawing power from the grid? So that's a key area where a lot of optimization technologies are being used to optimize generation and distribution in microgrid.
Okay, thanks. So I come from marine industry, Lloyd's Registers focusing on marine industry. So we use artificial intelligence more and more for, again, predictive maintenance as well as optimization of oil and gas as well as in the shipping industry. So now, when it comes to AI, like in marine industry, we are talking about autonomous vessels. Right? Even today, Singapore is doing some trials on petrol vehicles, and the vessels in the water, actually. It's coming back to insurance industry, actually, because now there's a lot of self-driving cars happening, autonomous vessels are coming up, autonomous trucks are coming up. How the insurance industry is going to deal with, autonomous vehicles, actually?
I think it's an interesting area for us because traditionally any insurance company writing property and casualty business, they will have a very large motor book. So typically, let's say 50 to 60% of the premium on the P&C side will be coming from the motor today. And the reason is simple because a lot of these motor insurance is mandatory traditionally in all the countries. That's why you have traditionally a lot of business coming in that line of business. Now this is getting threatened by two areas. One is autonomous vehicles. So when they will come, what will happen to the risk? Because the car that somebody is buying then will not be driven by a person. So maybe people will not have to take the insurance. It will be the company who's manufacturing those autonomous vehicles probably would have to take the insurance cover. So there is a transfer of risk and transfer of the way things will evolve on this aspect. The other dimension to that is also that in the autonomous vehicle area, if we can perfect it, we can reduce the accidents by 90%. Because today 90% or 90+% of the accidents are because of human error, and 6 to 7 or 8% is because of machine failure or tire burst or whatever. So a lot of it, which is human error, will ideally reduce, and it will transform into a completely different risk form. One of the risks which we believe will increase is clearly going to be cyber risk, basically. Because if somebody hacks into the autonomous vehicle, which is driving on its own, and does an accident, then obviously that component will clearly increase. So we see that there will be a change in the way risk will be there. It will be a huge impact on all the insurance companies because motor traditionally will ideally reduce in terms of premium and in terms of the revenue. And there will be a shift, basically. Even on the marine side, there could be, as you said, there will be autonomous vessels and those kind of things. So we see a lot of these things will happen. In AXA, we are participating in a lot of these programs to understand what will be the change in these risks and how do we adapt the insurance product or the cover eventually to these new risks which are emerging. But our belief is that it is still 3, 4, 5 years down the line. But gradually, you still have a lot of automation which is happening, which doesn't mean that it is full automation, but it is, let's say, assisted driving, which is real now, even assisted steering of the marine vessel. So although that is happening now, but maybe the full automation will still have a lot of, maybe another few years to go. But we are a part of it to understand how the risk is evolving and what is the implication for us on these things.
Lawrence would like to add.
Yeah, similar to what Ankur has been saying, I think we see shifting perspectives of risk. Now, if you look at the mobility industry, a lot of the insurers are covering driver, right? Covering the driver performance, right? If it gets an accident, the insurance covers the driver's behavior and the accident itself. So I think in the evolving world of autonomous driving, we see more and more of this risk being shifted away from the driver and into software, right? So more and more of these autonomous vehicles will be powered by AI. We start to think about new areas of risk and where we can cover those risks. And also an emerging area is the passenger, right? So if you're a passenger in an autonomous car, you may be exposed to other types of risk which was not previously present in a driver-driven car. Right? So these are shifting perspectives. I think we are still trying to navigate the space of what is the right cover, what is the right premium, who should we play, who should we partner. I think we're just really at the beginning stage of all these transformation.
A question for Dr. Segret. So in a high speed and high volume transactions in this platform, because now we are depending more and more on trading algorithms, right? How do you ensure that these algorithms runs without any error actually? Just small error, because fraction of error can cause a major disruption in terms of dollars, in terms, trading. How do you ensure these algorithms are validated and it runs in an optimal way?
Sorry, I didn't get.
I'm asking because so you run a lot of trading algorithms on the platforms. Okay. So how do you validate those algorithms?
Okay, so
without
as
any
an
error?
exchange, we don't trade. So we just operate the platform. So we don't run any algorithms. What we do a lot is looking at how customers behave on the platform. So we spend a lot of time looking at what customers are doing. So for us, customers means a lot of different things. It could be a retail customer, so it could be like you and me trying to buy a Singtel stock or selling an OCBC stock. It could mean institutional investors. So institutions, typically, some of them will do high frequency trading. So the way they behave is very different from a retail customers. Customer also could mean different markets. We operate two markets. We operate a securities market, which are the usual stocks. We also operate derivatives market. So every single piece in here is very different. So the way we look at customers as customers is always different. And what we are trying to do now is map all these different pieces together. So how, if you start trading in the securities market, would you also be able to trade in the derivatives market? Is your behavior different in these different markets? Are you also we also look at other things like connectivity, because how fast you can access the market will also have an influence on how much money you can make. So we do a lot of things around latency, making sure that you have the best access. So what we are doing right now is trying to piece all these different things together to see, for example, if I place this amount of orders, how is it going to influence my trades? Do I have any experience on the latency side? So being able to map the whole customer journey in this sense, so that's a lot of the efforts that we are doing. So the first touch point for us, the customer, is when they reach the website. Then they will start opening an account with us to have a custodian account to keep all the stocks that they are buying. Then they open a trading account, start trading. So really trying to understand all the different behaviors so then we can provide better products, better services for our customers. This is what we are spending a lot of efforts on.
Thanks. Now, it's a question for everyone, because we are using AI more and more in everyday, day-to-day life. I would like to ask a question that ethics of AI, because Singapore government recently released the AI governance framework. How each and every one of you are adopting to that AI governance? How do you really use AI, and how do you really comply with the AI governance? You want to talk? Dr. Pathak would like to start.
Yeah, as mentioned previously, the scope of AI in SEMCorp is about managing operational efficiency of our processes. So in its entirety, the concept of ethics is probably a superset of what I would consider as trustable AI. Yes, absolutely, when we build an AI solution, our business has to have a sense of trust on it, because we are essentially saying to an operator who is used to running an operation for decades in a certain way to change and adopt a totally different way. So there should be an element of trust. And coupled with that, the issues we face is in the area of cybersecurity more than ethics in particular. So yes, we do have robust processes in place. Within digital, we have cybersecurity team, and within data science, we have stringent data governance, data quality processes in place, so that when we build a solution, I referred to the presentation done by Dr. Terence before when he talked about how do you convince an engineer with the AI you build, and that's about the usability of the tool and how much he or she can refer to the functionalities and relate to it. So that's all part of the change management process that we follow from the day one of any data science initiative. So we bring the operators along, the engineers along the journey to ensure that whether it's ethics, again, it's a superset of what we do, but trust and security are not a nice thing to have, which is always as an afterthought, but it's integrated within our processes from day one.
So I think there are a lot to do the ethics with fintech. So would like Lawrence, Dr. Sigrid.
So on the ethical part, to me, there are three main parts. The first one is the government. So recently, MAS has released guidelines for the finance industry on how to use AI. I'm sure you have heard about the FEED principles. You can go and look it online. But those guidelines are very broad. So now it's up to the company to start interpreting it. So the second player is the company itself, and is how they will interpret all these guidelines. So we get advice from the board and from the upper management on how we can apply those principles in-house. But I think a third player is the data scientist. And to me, the data scientists have a big responsibility when they build their models to start thinking of all the ethical implications of what they are building. So is my model fair? Is my model going to introduce bias? Can I have the right checks in place? So as a data science team, we also have our own guidelines and our own way on how we can make sure that we have good science and that the models that we build are robust. So we try to ask questions on the models, especially as we go more and more external. For now, we are still very internally focused, but as we go more external and we use those models to serve our customers, then we really need to start asking ourselves the right questions so that we are prepared for any bad consequences that could happen. Failure will happen, mistakes will be made, but the question is, how will you react if anything happens? So we are starting to think about all these things internally at all these different levels. So the government, the company, and then the data scientists.
Thanks. So I think we are running out of time, so I would like to have some questions from audience. So before that, I'd like to ask one question to Sotawong. In the recent past, there was a problem of revealing the blood data, the AIDS blood data, which was in the papers, which has been in the papers. So that is more about ethics, actually. How do we really keep the privacy of the data, especially in healthcare, Ministry of Health? So what kind of measures you have taken to prevent that happening in the future?
Sorry, are you referring to
the blood samples data, actually.
Sorry?
The blood samples data regarding the AIDS patients.
The HIV patient.
Okay. Yeah. Okay. So first and foremost, I have to clarify, I'm not authorized to talk about this. As a civil servant, I'm not authorized. It's beyond my pay grade. But my personal opinion, not ministry's opinion, right? A lot of times, right now, we look at innovation that is enabled by data. And of course, what has to go hand in hand is how we deal with the data in a safe and secure way. So privacy and security is important. Precisely because of that, we are looking into a lot of investments into privacy-preserving technologies. And if you look at AI, for example, some of the applications in healthcare, you look a lot into unstructured data. For example, the use of natural language processing or NLP on clinical notes to help diagnose appendicitis, for example, in the emergency department. We also use that to look at diagnosing diabetic retinopathy, which is one of the common cause of blindness among working adults. Right? This involves then diagnostic imaging. So a lot of this unstructured data, the key question that we have is that as part of a data access framework for analysts, for data scientists, is that we do not allow our analysts and scientists to look at identifiable data or to analyze identifiable data. And what we need to do then, of course, is to de-identify the data first. But of course, the biggest challenge when it comes to unstructured data, for all of you who have actually experienced doing it, is that it's never an easy task to fully de-identify the unstructured data, especially where in the clinical notes, the doctor can mention any identifiable information along the way for the clinical notes, right? And imaging, the same thing. So we are looking a lot into that. In fact, it's not just a health initiative, but rather it's a whole government initiative because we recognize that. And there's actually a coordinating committee for which I'm part of, for the whole government to look at the application of privacy-preserving technology, for example, differential privacy, homomorphic encryption, multi-party computation. So this is a very big area that we're all looking into.
Thanks. So we will take questions from audience. So before that, how many of you don't use AI? Almost everyone uses AI in everyday's life, from driving and using Google Maps, etc., etc. So I think you'll have a lot of questions on AI. So it's time for you to ask those questions to the panelists here.
Hi, this is Abhishek. I'm from Deutsche Bank. So one question I had was, I see in most of the panelists' name, I think you are part of some kind of data division. However, one trend which I notice is there used to be a lot of talk about big data only a few years back. But somehow we don't talk about big data anymore. In fact, even in the name of this conference, the word data is not even mentioned. Is it fair to say that the world has now moved from talking about large data sets and getting insights from those large data sets to instead talking about how we can use tools such as AI, such as machine learning, to glean insights from maybe smaller but more focused data sets? Or is there another reason we don't talk about big data anymore?
So I think a lot of it, if you look at the definitions, a lot of these definitions are quite jumbled up. So you will see a lot of overlap between AI, ML, big data, data science. So, and even if you go to technical definitions, they are very, they're cross, right? The way we look at it and we have thought about it and we said, okay, AI is thinking, perceiving, and acting. And for me, thinking part is the ML part. And big data, for me, is a subset of that in the big data, we are saying, traditionally, you are used to using a certain set of data, which is, let's say, an Excel file. And today, if you start using an R or a Python code, then it's already a big data for you. Today, if you were using a RDBMS or a tabular format of data, if you start using unstructured data, that is a big data. So big data, for me, is a subset of this, that you're actually analyzing a lot of voice data, real-time data, streaming data, as a part of this entire thing. And when we talk about AI, we are actually talking about, at least from my perspective, we are talking about analyzing all these things. For example, analyzing the images, which some of the panelists have spoken about, that how can we analyze image data, how can we analyze video data or streaming data, and take some decisions on it. So for me, your question, I mean, where is big data into all this? For me, it's a subset of this. But if you really go into the definitions, they're quite jumbled up, to be honest.
If I can share some perspective as well, actually to Jason's point earlier about the different world and different type of data, right? You have on the one hand a highly curated data, like in this case of clinical trials, where you have small number of records, but it takes an incredible amount of effort to actually curate and collect the data. On the other hand, you have data that comes from your wearables, and even things like, for example, now we are talking about precision medicine, right? Genomics data. These are big data files. Even if you don't look at the raw BAM file, go down to a more manageable level of VCF files, right? It's still very, very big data. But to me, it's not really about the size of the volume of the data, it's really about the insights. So I think regardless of big or small data, it's really focusing on the big insights. What are the key questions, the business questions that you're answering, and how then they can help drive business value. I think that's the more important part.
If I can just add to my co-panelists, totally aligned with what they have shared. I also think that in these days of hype, there is a bit of a shelf life concept of terminologies that come and go. So these days, the shelf life of a terminology is maybe a couple of years, then we need to move on. That's the reality from the marketing angle. But the reality on the ground level is that I don't think we have resolved the data problem in its entirety, and then we can close that chapter and move on to doing other better things. Yes, it has been resolved to a large extent, especially with cloud platforms maturing over the last few years. So if I were doing my job 5 years ago, I would be really bothered in managing the volumes of sensor data and other forms of structured and unstructured data. Now I am less worried, but still I need a strategy around data governance, data management, data modeling, data security before I can really build production-grade, trustable AI solutions. So yes, the attention is shifted because we have the platforms come in as a service, primarily through the cloud platforms as a service, which has sort of put those big, grainy problems to rest, but not entirely. So if you are, for example, if building a data science function, if you ignore that aspect, then I think that's a limitation. So for my team, I have big data architects, I have database and warehouse specialists, cloud platform specialists, and so on. So data science team doesn't have to be just data scientists.
So I think the big data is definitely important, the historical data, especially for teaching the machine for prediction, because based on the historical data, you can learn how we can predict some of the failures. We can stop some unscheduled maintenance, etc. But again, coming back to your small data set, the focus data for using, I think in terms of medical field, definitely we can use that, depending on how we are going to use it actually. Yes, I think you have a very valid question. I think more and more we'll use small data set to use it for AI actually.
There's one question I wanted to ask, is that IoT has been growing very fast. Like IoT is being used in every application from manufacturing to aerospace to land transport authority. And you know that for the last 5 years before, we have been using data centers, and then we moved to the cloud. Now everybody is asking edge computing. So now what is going to happen is like all this data what you're collecting is garbage 80%. The first question is that how you are going to clean this data, which you need to use it in the edge computing and then sending to the cloud with AI model or whatever the model you're doing. Is every industry in data analytics are really doing a predictive analysis, or we have reached to an extent where we have reached the predictive or prescriptive, or we are at the early stages of predictive analysis? Third is how the risk and security for edge computing and the IoT sensors which we are taking the data is secure, because we can alter the data even in edge computing, even in the data centers also. Now the question is, inside the drive, we have a lot of security. Inside the kernels, we have a lot of securities are there. So how do you manage that? What are the models that have been developed for that to make sure that data are good, it's predictive, and risks are reduced?
Just answer the edge computing question. Yes, because now we are going more and more on the edge in terms of IoT sensors, because if you come to shipping industry, marine industry, and also we come to oil and gas, so these are all very remotely located. So that means connectivity is a major problem. So logically using edge analytics in that environment is very important, because connectivity is very expensive. Also, you can't get a real-time connectivity to transfer such a high amount of data. Okay, so that's one thing. And second thing is also edge computing is very important to reduce even the latency. If you send everything to cloud to make a data, then your latency will be more actually. So that's the second thing actually. I did not really follow the second and third question. I think the third question was more about security actually. I think the security is becoming more and more important when it comes to sensors. If you look at the mobile phone, the protocol, 3GPP protocol, it offers a very, very secure, tunneling in terms of voice and data, etc. Even WhatsApp is a very encrypted message. So those kind of encryption is because when you're having edge analytics and edge computing in the sensor, we will have that kind of security on the edge side, edge devices. So because as we go and more and more sensors, we will also use a lot of security, embedded security in the edge devices actually.
If I can also add to that, because the concept of doing predictive analytics for our operational applications is very relevant to your question. And you asked a question which will take maybe not 10 seconds to answer, a little bit longer. And to me, it's both way. One is, yes, a lot of the data collected is not the most useful, or most productive. So how do I make a decision of what to store, what to analyze, and what to throw away? I've also seen the other end of the spectrum where in order to do predictive analytics truthfully and sufficiently, you need a lot more data than we have today. And how do I justify the investment needed to add additional sensors to, or with the additional sensors, add more granularity to the sampling rate that we have today? So it's both ways. It depends really on a particular use case. So for me, being pragmatic and taking this as a case-by-case approach is probably the best way rather than having a blanket strategy around IoT data. Depends what you want to do with the data, and there are solutions either way. You can oversample and get more granular, or you can undersample depending on the use case, depending on the data characteristics you have. So what is really important in this is whichever spectrum you are on, end of the spectrum you are on, is do you own the data? So my concern is more about, does SEMCorp own the data from the plants that we run and we are responsible for? If the answer is yes, then it resolves a lot of those problems. If the answer is no, the OEM owns, who provided the asset in the first place, then we've got a whole bunch of other commercial and legal issues to resolve before even we can get into the technical discussion. Okay. I hope that makes sense.
I think the time's up for a long time, so we'd like to close this session, yeah. Thank
All
you.
right.
So even if you have more questions, you can ask them during the networking session.
So if any of you have any more questions, let's take it off the stage. I'm sure the panelists will be available off the stage as well to take your questions. Thank you very much.